All right, so on this sheet here, when you look at your test, you can see all these like M1, A1, down here, there's a whole bunch of them. It says A1, M1, R1, A1, A0, A0, A0. Okay, I'm going to explain to you what those are. Here you see it again, M1, A1, bunch of them down here. Okay, all right. So what is all of that? All righty. So in IB, your grades or test questions are graded using what's called a mark scheme, just like a key. It's just another name for a grading key. And all of these things have different meanings, obviously. Okay. To review test mark scheme. So while we wait for that thing to load. Okay. So we gotta wait for this thing to load, and I'll show it to you. Okay, here it is. So the mark scheme looks like this, that this is what I work off of. Okay. So for example, on the first problem, the way that this stuff works is right now you're looking at what the official mark scheme for the first question. All right, when you see an M stands for method. So this first problem was worth 3 points. Okay, so the way that works is you earn 1 point, 1 method point for showing evidence of trying to get the vertex. Now there's lots of ways of getting the vertex. So what I do is I look at your paper. Is there some evidence on your paper that you were trying to calculate the vertex? That's what the M stands for. So if you don't get any method points, if it says M0, that's basically you didn't show your work. Okay, now the A stands for accuracy or answer. Okay, so there's 2 points for the answer. 1 point for getting that correct and another point for getting that correct. Right? So if you showed your work and wrote out this correctly, then your thing would say M1, A2. That adds up to 3 points. Now, if you got this answer correct, but you didn't show your work, you can't get answer points. So just having the answer without having the work supporting it, you don't get any credit for the answer. Okay, the only time that that's not true is on the very last question when you were told you can do it on your calculator. All right. Now, you might have used your calculator to do this first question, but you can't use it as a reason on how you got your answer. Okay. All right, so I'm just going to go through the test now. And what I would do, especially if you're going to be retaking it, is I would copy down the solution. So the makeup test will be the same types of questions. It won't be the same numbers, but it'll be the same types of questions. And so it would really help you if you did that, okay, if you want to improve your grade. And I'm thinking of doing the makeup. I haven't written it yet, so I need a day or two to do that. So we'll do it probably Wednesday or Thursday during celebration, after school, etc. All right, so here's the key on each problem. So for M1, you needed some evidence of obtaining the vertex. All right, so probably the quickest way of getting the vertex is to use this formula. X equals the opposite of B divided by 2A. That's going to give you the X coordinate of the vertex. Okay, so in this case, that would be the opposite of 4, and then 2 times 2. So that's negative 4 over 4, which is negative 1. So that shows me that's what evidence is. Okay, then take that and plug it into the equation to get the y coordinate. So then the y coordinate of the vertex is going to be 2. And wherever I have an x, I'm going to put in 1. So the part of when you're doing this, guys, and some of you do a really good job showing your work, and it's organized, it's not scratched out. It doesn't look like you are, having some sort of nervous fit. Your writing's all over the place. It's neat, it's labeled. So the easier it is for me to follow what you did, that's to your advantage. 2 minus 4 minus 6, which is negative. So this is how you earn the method point, by showing this kind of work. Okay, and then the answer point was just plugging it in. So that would be y equals 2. Now, when you plug in minus 1, it becomes plus 1 squared minus 8. And there's this was the 2 A points. So really, this is what was critical. That's the evidence that shows how you got your answer. So evidence isn't I did it in my head or I looked at the calculator. If this had a little calculator symbol by it, then you could do that. But no calculator symbol. All right, axis of symmetry. Well, we already did it. That's why it was only 1 point. You did it right here. Okay. So the axis of symmetry is the x coordinate of the vertex. So you already did it. So that's x equals negative 1. This is a vertical line. Okay, and then you had to write it in intercept form. Okay, so show evidence of converting this equation here into this equation. Okay, now most of you did it by factoring. Okay, some of you did it by completing the square, but I've got to find the x-intercepts, so I'm going to do it by factoring. So I'm going to take this and set it equal to 0 and factor it. 2x squared plus 4x 6 equals 0. Okay, factor out the 2. And then this factors to x plus 3, x minus 1. Okay, so then 1 root is negative 3, and the other root is positive. So that's what I looked for on that, and then put those into the equation. Okay, so x minus negative 3, x minus. So you always got to ask yourself, do you have you provided evidence of how you got your answer? Okay, the next problem was the one that probably most people missed. Okay, that was probably the hardest question, I think. Yeah, number 2. Some people nailed it, but out of everybody, it was probably the one that took the longest to check. Okay, so if you look at all these points here, first point was, did you rearrange this? So what I looked for that first one was, did I see somewhere in your work that you moved the 4 over? That's what I looked for first. Okay, then it's asking you to find 2 distinct real roots, which means you're going to have to do the discriminant. So when you have 2 distinct real roots, the discriminant has to be positive. So then what I looked for, did you somewhere calculate the discriminant? So I looked at your work and looked for evidence of that. So in that case, the discriminant would have looked like this: negative 3 squared minus 4 times A times C. So I looked for this. Okay, and then we got a point for correctly solving this. So let's, this was 9. Okay, minus 4 times 1 is just 4. So this is 4k squared, 4 times negative 4. So that becomes 9 minus negative 4 plus 16 because of that negative. So then I looked for, do you somewhere on your paper have this? That's the discriminant. And most people did okay up to that point. Okay. Now, it was here where we kind of got a little mixed up. All right, so from this point on, what we want to do is we want to find the values of k that make this greater than 0. Okay, so we need to find the values of k. values of K that make (25 minus 4K) greater than 0. So that was the next thing I looked for. In your work, did you somehow have the discriminant greater than 0? That's the reasoning point. Now, if you didn't write it like this, but you had it on your sign chart, then I counted it as a reasoning point. So you might see on your paper like that. On your sign chart, I wrote R1. If that showed that you knew that the rate or the discriminant had to be greater than 0. All right, now to solve this, okay, find the roots. So I'm going to find the roots by setting this equal to 0. Okay, and now I subtract 25. 5, and then divide by -4. Okay, so I end up with this. So you're not solving this with an inequality in it. This was the mistake that a lot of folks made. They did this, and they moved the 25 over, and then they divided by -4, which meant they had to switch the inequality. Okay, you can't solve a quadratic inequality that way. Okay, you got to find it 0. So I just did. So then the next thing I wrote here was when I do the square root, you should have plus or minus 5/2. Okay, so that's this A point right here. Correctly solves for the roots of the discriminant by setting it equal to 0. And you listed both roots. That's this point. So I looked on your paper. Do you have plus or minus somewhere? 5/2. All right. Now, to solve this, you have to use a sign chart. So I put on here 5/2, -5/2. And now what I'm going to do is I'm going to test numbers from these 3 intervals. So I'm going to pick a number to the left of -5/2, like -3. Okay, so I'm going to plug -3. So here's how you test it. Okay, 25 minus 4 times -3 squared. Okay, that's going to be a negative, which means this interval is going to be positive, and this interval is going to be okay. And now identify the interval. So you want to know where it's positive. So that's between these two. So if k is smaller than that, but bigger than that, that's your solution. So again, you might have had that, but if you didn't have the work that led you to that, you didn't get credit for it. That was probably the toughest one. But I just wanted to give you an idea of the detail of work you got to show. Just think, have I provided evidence on how I got it? That somebody would understand without reading my mind. I used to be really good at reading minds, but not so much. Okay, the next problems, none of them are nearly as involved as this one was. All right, following diagram shows quadratic function. Its vertex is at 1, -9, right here. 1, -9. And across, there's the y-intercept, 0c. And it says write it in, write down the values of h and k. Well, this is h, and this is k. So that one was pretty easy. Now, I also accepted if you put it in the formula. So if you wrote it in the formula, okay, h is 1 and k is -9. All right, how to find the value of c? Well, take this equation and you take out the x and you put in 0. So then what I looked for is somewhere on your paper that looked like this. 0 minus 1 squared minus 9. So that's 1 minus 9, that's -8. So I looked for evidence of you taking a 0 and substituting it in for x. All right, now on 4a, it seems like people get confused on Bizarro World. Okay. Thinking, okay, the roots are actually the opposites. Okay. If you think of it this way, the x-intercepts are the values that make either this equal to 0, which would be 1, or makes this equal to 0, which is -3. Okay, so you could have written x equals 1 or x equals -3. Or you could have written it like this. This is your -3. So that one was just looking at the picture. All right. 4b was find the coordinates of the vertex. So here's what I looked for. Evidence that the student recognizes the x-coordinate of the vertex is halfway between the x-intercepts. Okay. So to earn a method point, I looked on your paper. Do you have this somewhere? That's the x-coordinate of the vertex. It's halfway between the two intercepts. Okay, and then to get the y-coordinate, you just substitute that in. Okay, so you properly got x equals -1. And now the next thing I looked for, you're going to take that and put it in to this equation. Okay, so the second part was to get the y coordinate of the vertex. I'm going to take out the x and put in -1. This used to be x minus 1, x plus 3. So I just took these x's out and I put -1s in their place. That's all. -1 -1 plus 3. That's your other coordinate. So this is the evidence on how you got your answer. Okay, 5A. You're given this graph. Okay, so you got -2, 0 right there. You got the y-intercept, and you got the other x-intercept. And it says write it in this form. Well, these are your x-intercepts. So to write this out, all you're going to do is drop in these two numbers. So I'm going to put -2 in here, and I'm going to put 4 right here. And that's it. So p x plus 2 x minus 4. Now, that's the equation. The question said, what's Q and R? So Q is that number, and R is that number. This really wasn't part of the problem right here, the equation. It's just asking you for Q and R. If you plugged Q and R in, it equaled that. But that's all you had to do for 5A. All right, axis of symmetry is halfway between these two numbers. So halfway between -2 and 4. All right, number 5C. Okay, to get a method point, I needed to see evidence that you took the y-intercept and you put it into this equation. Okay, that's the same one we got up here. So I looked for something on your paper that looked like this. 0, or the y is -4. Then p, and then you put a 0 in for the x. And then you solved it correctly. And divide both sides by 8, negative 8. And you get P is positive 1/2. All right, number 6. And guys, I'm recording this, so if there's any, I'll post this on the classroom of me going through it if you don't get everything. All right, so first of all, did you show evidence that you solved this? And most people did factoring or the quadratic formula. Okay, I'm going to do it by factoring. All right, so I'm looking for two numbers that multiply together to be negative 6 and add together to be positive 5. Those would be 6 and negative 1. So I got to multiply to be negative 6 and add that. Okay, and then I set up my box. Okay, 3x squared negative 2. And then I put these two in the other two boxes with an X on them. Okay, and GCF it. GCF of 6x and negative 2 is 2. GCF of 3x squared and negative x is just x. And then do them downward. GCF 3x. GCF, since there's a leading negative, I'm going to pull out a negative and it's. So then what I looked for is, do you have this somewhere on your paper if you were using factoring? All right, then you had to find when is this quadratic greater than or equal to 0? Okay, so did you show evidence of using the roots to determine the x intervals where the quadratic is greater than or equal to 0? So I just looked at this. You set up your sign chart, negative 2, 1/3, and then you put tested numbers. So let's say I test negative 3. $27 plus negative 15 minus 2. That is going to be positive. Positive, negative, positive. So this was negative infinity to negative 2, bracket, 1/3. And I'll go over this one real briefly tomorrow. It's pretty easy. Okay. So if you need help going through these again, I'd come in during, whatchamacallit,